Assalamualaikum. My name is Nur Hidayah binti Sharizan. My matric number is 20139158. Today I would like to present my assignment 1B for subject antenna and propagation. The first antenna is patch antenna. This type of antenna is usually used in Wi-Fi and other wireless communication system. There are three characteristics of patch antenna that I want to discuss, which is patch antenna are suitable for application that require a compact form factor due to their low profile construction. Patch antenna are popular for their small size, which make them suit for application with limited area. Another characteristic is easy to fabricate. Patch antenna are usually printed or etched on a flat substrate. Based on the design and operating frequency, the gain for patch antenna are commonly ranged from 5 dBi to 12 dBi or more. The radiation pattern of patch antenna can be either omnidirectional or directional. The second antenna is Yagi-Uda antenna. The Yagi-Uda antenna is usually used for long-distance communication. The characteristic of Yagi-Uda antenna often have a relatively small bandwidth, which means they are made to function well in a particular frequency range. In outdoor setting, Yagi-Uda antenna are frequently employed for wireless point-to-point communication, which is radio communication and TV reception. The gain for Yagi-Uda antenna is commonly ranged from 6 dBi to 20 dBi or more. The radiation pattern for Yagi-Uda antenna is directional. The third antenna is dipole antenna. Dipole antenna is a simple and popular type of radio antenna. It is made up of a straight conductor or wire that has been divided into two equal parts and fit in the middle. The characteristic of dipole antenna is the electric field of wave transmitted or received by a dipole antenna has a linear polarization, which causes it to oscillate in one direction. Dipole antenna are ideal for broadband application because they can operate over a wide frequency range. The gain for dipole antenna is 2.15 dBi in free space. The radiation pattern for dipole antenna is omnidirectional. This is the parameter I use to design the graph of receive power for different environment, which is urban, suburban, and rural area. It is also used for design a graph of receive power in free space path loss. For the parameter contained in this assignment is the operational frequency is 900 MHz. The distance is from 1 km until 20 km. The transmitter height is 70 meter. The receiver height is 10 meter. And the transmitting power is 30 dBm or 1 watt. The gain of the patch antenna at frequency 900 MHz is between 0 to 3 dBi. So I choose the gain for the patch antenna as 3 dBi and the gain for Yagi-Uda antenna at frequencies 900 MHz is between 6 to 10 dBi. So I choose the gain for the Yagi-Uda antenna is 7 dBi. And the last antenna is dipole antenna. The gain for dipole antenna at frequency 900 MHz is between 2.15 until 3.15 dBi. So I choose the gain for the dipole antenna is 2.15 dBi. This is the graph of received power for urban pass loss and free space pass loss with 9 different combination antenna. As you can see, on the right side is the graph of received power in free space pass loss, and on the left is the graph of received power in urban area. For both graph, there are 9 combination of the antenna, which is patch to Yagi Uda, patch to dipole, patch to patch, Yagi Uda to patch, Yagi Uda to dipole, Yagi Uda to Yagi Uda, dipole to patch, dipole to Yagi Uda, and the last one is dipole to dipole. As you can see in this graph, the combination of patch to Yagi Uda and Yagi Uda to patch antenna is overlap. This is because both combination have the same value of receive power. It also can be seen in the combination of patch to dipole and dipole to patch, and the combination of Yagi Uda to dipole and dipole to Yagi Uda. Based on this graph, I can conclude that the receive power in free space pass loss is better than the receive power in urban area. This is because the value for receive power in free space pass loss is higher than receive power in urban area. In free space pass loss, the signal propagates in clear space with no obstruction or interference. As a result, receive power decrease as transmitter and receiver distance increase. While in urban area, the signal is constantly obstructed by various objects such as tree, building, and other structure, which cause pass loss, reflection, diffraction, and multipass effect. The receive power is decreased due to the distance increase and the presence of obstacle. Next, this is the comparison of receive power in free space pass loss and receive power in suburban area. Same as the previous slide, there are 9 combination of the antenna that will be appear in both graph, and there are 3 combination of antenna that will be overlap. Based on this comparison, the receive power in free space pass loss is better than the receive power in suburban area. This is because the value for receive power in free space pass loss is higher than receive power in suburban area. As I mentioned before in the previous slide, in free space pass loss, the signal propagate in clear space with no obstruction or interference. The receive power decrease as the distance increase. Suburban is a combination of residential, commercial, and industrial zone together with some building and structure. In comparison to urban area, suburban area usually have lesser patch loss and multi-patch effect, which lead to slightly smoother receive power change with distance. Building and structure in the suburban area have an impact on the receive power, which might result in pass loss. This is the comparison of receive power in free space pass loss and receive power in rural area. Same as the previous slide, there are 9 combination of the antenna that will be appear in both graph, and there are 3 combination of antenna that will be overlapped. Based on this comparison, the receive power in rural area is better than the receive power in free space pass loss. This is because the value for receive power in rural area is higher than receive power in free space pass loss. In contrast to urban or suburban area, rural area are characterized by low population density, wide landscape, and very few barrier and construction. Hill and valley, as well as the distant from the transmitter might have an impact on the received power in rural area. In contrast to urban or suburban area, rural area tend to have less pass loss and multi-pass effect due to the absence of dense building and structure. In free space pass loss, the signal propagates in clear space with no obstruction or interference. The received power decreases as the distance increases. Receive power in rural area is the best among the others environment due to fewer obstruction, favorable terrain, increased freshness zone clearing, reduced noise, and probably terrain gain. The rural environment may show better receive power compared to the free space pass loss model throughout a distance range from 1 kilometer to 20 kilometer. In conclusion, I can say that the combination of Yagi Uda to Yagi Uda is the best combination in terms of received power. A wireless communication system received power is greatly influenced by antenna gain. Antenna gain for Yagi Uda is the largest than patch and dipole antenna. In a wireless communication system, high antenna transmitting gain and high antenna receiving gain are advantageous for received power. They produce a stronger, more concentrated signal, improving link performance, extending the range of communication, and enhancing signal quality. That's all from me. Thank you for watching.